Hi, everyone. Welcome back. I hope you enjoyed a good networking session and perhaps met a new colleague or two. So here, I want to introduce our fireside chat with John Bohannon and our CI fellow, August Jackson, whom you met earlier in the day. So they'll be talking about putting OSINT at the heart of insights. So with that, I want to turn this over to August Jackson and John Bohannon, Director of Science at Primer AI.
Okay. Thanks so much, Cynthia. Hey, John, how are you doing today?
Great.
All right. So for those of you in the audience, I'd like to give a brief introduction to John and his background. John Bohannon is the Director of Science at Primer, an AI startup based in San Francisco. There, he's built and led a team that has achieved state-of-the-art performance in machine learning, created self-updating knowledge bases, and delivered counter-disinformation systems for the U.S. government. Before joining Primer, he was a data scientist and an investigative journalist. While embedded with military forces in Afghanistan, he engineered the first voluntary release of civilian casualty data by NATO and the United Nations. One of the things that's really interesting in John's background and noteworthy is some of his acts of gonzo investigative science journalism, where John and his team submitted, let's say, fake and flawed scientific articles to fee-charging open access, supposedly peer-reviewed publications, made some very important revelations about that particular industry. And that'll be very relevant to this conversation and your background at Primer as well. And John's work also explored flaws in how mainstream publications report on supposed scientific research, in the case of his investigation about diets and dieting, as just one example of how mainstream reporting on science themes falls short. This is very important work considering the role of peer-reviewed publications and the importance of scientific journalistic coverage in our world today. So John, I'm really excited to speak with you. Thank you so much for joining us. Is there anything you'd like to correct or add to that introduction?
No, thanks. It's a good slice of my life there.
Yeah, and you've got such an interesting background. You know, you've worked in these supposedly very disparate fields. You know, you've got your background in data science. Your PhD is in microbiology. You have a career in investigative journalism, and the work that you're doing at Primer AI. I was wondering if you could talk a little bit about what are some of the common threads that you see among those fields and how they relate to OSINT. Yeah,
that was something that was on my mind when I was very pleased to get the invitation to talk to all of you. I first had to figure out what is competitive intelligence. I have to admit, like, I don't really understand what the industry is, but now I'm starting to get my head around it, especially because recently I've worked with a competitive intelligence analyst through Primer. And what struck me is there is a job that has tons of resonance across all of these different fields. So competitive analysis has huge overlaps with the intelligence community, the kind of work that an analyst in the intelligence community does, and it has huge overlaps with what a journalist does. So I think of a journalist as an intelligence analyst who works for the public. And, you know, an intelligence analyst works for the government, and a competitive intelligence analyst works for a company or an industry, you know, clientele. And the day-to-day of those things is very, very similar, actually. They face a lot of the same problems. They use a lot of the same tools. And at the center of the Venn diagram of all of this is OSINT. It's the marketplace of information that we're all swimming in.
So digging into that, what are some of those common problems that you see that all of these fields face?
Well, I'll start from a journalist point of view. You know, the motivation of a journalist is to uncover what is not known, and it has to be newsworthy. So, you know, when your customer is the public, your readers are the public, there's all kinds of constraints on what counts as news. It could actually be extremely interesting and valuable to a few people, but it might not count as news because you're writing for hopefully a larger audience. So, you know, what a journalist is looking for is what does the public need to know? What's going to be truly of interest? And then what you have to do is figure out, where am I going to get that information? Now, if you're relying entirely on OSINT, doing no fresh reporting, getting no, information that isn't already in the public, you can still tell great stories. That's the amazing thing, especially these days. There is so much information right in front of us that just hasn't been put together. There are analyses that just haven't been done. And so you can create fresh insights on top of open source information. And they do that day in, day out. And indeed, a lot of the biggest stories actually come from just putting it all together on OSINT. Increasingly, it's a mixture of social media, news media, reporting, and information that's on websites or hidden in government, publicly accessible government data. It's all out there right in the open. And sometimes the reporting you have to do is just on top of that. So you get a few sources, a few insiders, you vet, you get kind of commentary, maybe a few key new insights. And that is probably 90% of journalism. That's 90% of the media that we consume. On the competitive analyst side, similarly, right? The information you're getting about the industries you're analyzing, it's largely right there in front of you. You just have to go hunting and pull it all together. And the value you're bringing is the analysis on top of it. But I was so impressed by this one competitive analyst that I worked with recently. I mean, the sources he was getting, the access, I don't even know how he pulled it off. He could just call up, CTOs at companies, and they would talk. Clearly, they would talk to him. I was really impressed. I think some of the best competitive analysts probably could change careers in a snap if they wanted, and work in journalism, work in the intelligence agencies.
Yeah, good to know that there might be other career opportunities out there should that need arise. Because the process that you're describing, John, for investigative journalism is very, very similar to the standard competitive intelligence project approach as well. And that mix of OSINT, primary intelligence, of various forms, usually human intelligence or human, and then of course the analysis that really makes that all mostly is the basis of making that valuable and useful for our stakeholders. In terms of this particular analyst, the competitive intelligence analyst you've been working with, that can get people to talk, just a quick segue into primary intelligence and elicitation. How do you do that? It's so there's a whole methodology around it, and I'm sure our chat session is going to just explode with people talking about elicitation and the different methodologies. But it's one of the things outside of the profession that I think always amazes people is people's willingness to talk with just a little prompting, some structure around the conversation, and there's a whole science to it. But it's very powerful when you.
I mean, that was my experience as a journalist as well. Most people do want to talk.
Yeah. Mm-hmm.
You come knocking and you're really interested in their world. Most people do want to talk.
Exactly.
Sometimes in the face of real exposure and risk.
So I'm not going to name names, but I do have an anecdote of one time where having dinner with somebody I knew from a previous stage of life and drinks, yes, at least there were some drinks involved, but who worked for a competitor, and he started sharing something very sensitive. And I said, stop, my professional code of ethics requires me to tell you, you know who I work for, you know what I do, you are telling me material information, you should stop. Kept on talking anyway. So in that case, I didn't get to use my elicitation skills, but anyway, people are willing to talk.
By the way, there's another side to this though. Although we have so much in common, in terms of like the material we're working with and the kind of insights we're trying to get, I think there are different challenges. There are a lot of challenges we share in common, but the things that make your job hard are probably slightly different in competitive intelligence versus journalism versus the intelligence community. A lot of overlap. And that's that's the space that we're in. We're trying to find those common denominator problems and then build tools to help. But I think there are probably, that's where the difference lies. It's not so much your goals and your techniques. Probably it's like, what are the blockers? Yeah,
I definitely agree with that. So, and you mentioned tools, that's I think a good opportunity to pivot, because one of the things that I always like to do whenever I'm involved in a discussion and we're talking about, some amorphous terms, like artificial intelligence and natural language processing, is say, let's get a definition of this. So John, if I could put you on the spot, what is your definition of natural language processing?
Yeah. Let's start at the top. There's something that everyone is calling AI these days.
Mhm.
So
Mhm.
artificial intelligence, that's the most nebulous. You'll get a different answer depending upon whom you ask. I think it's kind of like what people used to call the God of the gaps. So as our picture of how the universe works kind of like gets sharper and sharper through scientific progress, the things that can't be explained yet, we call that God. And I think artificial intelligence is kind of like that. You do you happen to remember when really good translation really started? Do you remember? It was like just a few years ago. It was not that
Yeah,
long.
it was really not that long ago.
And it was terrible before that.
Yeah.
I mean, I remember
Yeah.
one of the earliest translation programs, we would use it as a joke to make gobbledygook text. So you would translate from one language into another and then back again, and it would just fall to pieces.
Yeah, loved that.
And nowadays, I mean, it's just astoundingly good. On Slack within Primer, I just like a few weeks ago, we had a Chinese tea party. So the idea was you would go in and in Mandarin, just like have some chat. And I came in using Google Translate as the input and output to see if I could take part. And a lot of people didn't realize that I had no knowledge of Mandarin, and yet I could hold forth in this conversation just fine. That shows how far we've come. Is that AI? A lot of people probably don't feel it is anymore, and I'm actually with them. I don't think it's artificial intelligence. I think it's just it's applied mathematics, really, at the end of the day. We take it for granted because now it works. It's like, oh, well, that's just a tool. Artificial intelligence is like human intelligence automated. And I think it's all the stuff that we can't do yet that we call AI. That's how I feel. Now, below AI is a whole set of techniques called machine learning, and especially deep learning, which is a kind of machine learning. And that's basically what everyone has used for the past 10 years and works. Before deep learning, it was so hard to make anything work. And deep learning just really cracked the code, first in computer vision and now in language. And so within deep learning and machine learning, there is a branch that focuses on language, and that's called natural language processing, just for weird historical reasons, or NLP. And it's these days it consists of a set of tools, a surprisingly small set of tools that have only existed for 3 years. And before that, I can tell you, because I was at Primer before it, everything was so much harder. If you wanted to solve a problem involving language, it was just, you would have to make a beautiful butterfly bespoke solution with tons of code. Imagine if then rules, but on steroids, pages of them, and clever statistical techniques. And then almost overnight, we had a new technology called transformers. That's actually a neural network architecture that then were applied to make a thing called a language model. And the first most famous of them is called BERT. And it was created by a team at Google, and astoundingly, they just open sourced it. They just let anyone have it. And then thank goodness they did, because then everyone got in the game. Facebook, they made models and put them out open source. Microsoft has gotten in the game. Counterparts in China. Now we're awash with these massive, powerful language models, and you can use them to do work on text. All kinds of useful stuff.
Okay. And then what are some of the things that you do when you're applying them to text? What comes out the other side of that? Yeah,
I think of them as Lego bricks. And I really mean that. It's like they're fun to play with. They're like toy-like. They've gotten the tools around them have gotten so nice and easy to use. They're like little Lego bricks. So, for example, let's say that I am at a company with a whole department that just deals with customer communication. So messages are rolling in from customers. And first thing you need to do is figure out what kind of message is this? Is this a complaint? If so, should legal be worried? Is this some kind of just nice comment? Is it a request? Is it for information? What is this? And you have to figure out which bucket it goes into so that you can deal with it appropriately. That is just a task called classification. Put this text into the right bucket. And I've decided what buckets exist. We now can make a little Lego brick that just does that. And you just train it on a little bit of data. It could take as little as 2 hours of teaching the computer what you mean by this bucket versus that bucket, depending upon how complex the task is. And then it's off and away, and you don't have to do that again. You can tell all those people who were spending tons of their actual time putting things in the right bucket, and you can free them to do more interesting things. So I think of it as like the spreadsheet. So when the spreadsheet arrived, people who work with numbers had their lives changed for the better, for sure. And there was a time when you would have a hand calculator and a piece of paper called a spreadsheet, and you would just have to do all this work just to do the basic math, to do things like accounting and so forth. And then suddenly we had a spreadsheet that automated tons of that work. And it's like those jobs didn't go away, they got transformed. Now you can actually do interesting human work, creative, synthetic, have good judgment on top of things, analysis. NLP is the spreadsheet for language. So that's what's coming. We're going to see all of this knowledge work, including competitive analysis, and anyone who has the word analyst in their job title, I think is going to be the first big beneficiaries of this. They're going to get a technology akin to the spreadsheet, but for language.
So I appreciate the fact that you referred to the analysts as the beneficiaries of this, because overall, I do tend to agree. And the calculator and the spreadsheet analogy is a great one. And I think one that we can abuse a little bit more if nobody minds. When the calculator was new, one of the things that was theorized at the time was basically this will end the career of an accountant. We won't need accountants anymore because we have calculators.
Calculators or spreadsheets?
Well, I'm starting with calculators because
really?
Spreadsheets came on. Yeah.
Because there was a human job. They were called computers.
Yes, exactly.
Yeah.
Yeah. People, rows and rows of people in, sitting at desks in, Aberdeen, Maryland, and places like that, working on ballistics and that sort of thing. Yeah, IBM. Exactly. Well, so first it was the calculator. Well, that's going to get rid of the accountants, and then it was the spreadsheet, and it's like, well, that's going to get rid of the accountants. And I think one of the things that frustrates me a little bit with some of the pitches that I see from not Primer, mind you, but some of the the AI and NLP technology vendors out there is this idea of this tool you will no longer need a competitive intelligence team, or you will no longer need intelligence analysts and that sort of thing.
No way.
Yeah. Yeah. And one of the reasons I think the analogy is so great is before I was at Deltek, the software company, I was at Ernst & Young, this accounting firm that was over 300,000 people, was, one of the big four, but is itself, one of hundreds, if not thousands, of accounting firms in the world. I was like, well, why do we have all these accountants if we were supposed to have gotten rid of them with the spreadsheet? And in fact, the spreadsheet has empowered that profession so much more. Yeah.
Yeah. I don't see expert humans disappearing from much of knowledge work. I just see them getting massively empowered. And those who take advantage of this technology will be the ones who edge everyone else out. So just like you have accountants who are wizards at using spreadsheets, you're going to have analysts who are just wizards at using NLP tools. I don't think it's going to be called NLP, by the way. That's like engineer speak. I don't know what we'll end up calling all this stuff. We'll see how culture evolves around it.
So a while ago, you mentioned Lego bricks, and I think that's a great analogy. In one of our previous panels, the topic of low code and no code came up as well. Would like to get your perspective. Are those, Lego bricks, is that the low code, no code pieces that the analyst puts together, or what's your perspective on that?
Yeah, that's exactly right. It feels like Lego bricks even to me. I'm like writing in code and dealing with it as code, but even at that level, it feels like Lego bricks, because like with 3 lines of Python, I can instantiate and train a machine learning model to do work for me. I mean, when you only have to write 3 lines of code, that's a Lego brick. You know, that's a beautifully easy, delightful situation. But I think for an analyst who doesn't code, it's not going to be long before it's a drag and drop GUI experience. You know, like, so going back to that example of, let's say you run a department in a huge company of 100 people, and they're dealing with all these customer, flow of customer text. The dream is you just go into a little web page, in this app, and you essentially make a factory floor. You're like, okay, well, here's the pipe of the text coming in. I'm going to first put a little classifier here that's going to figure out which of these lines it goes in. Then if it goes this way, I want these things to happen. If it goes this way, this happen. Maybe some conditions, if then, some alerts, power a dashboard so that we can keep track of the flow, and, blink red lights if there's anything worrying. And maybe I can run this entire department with 10 superpowered people and free all those people to do more interesting, more useful work. There's no need to have 100 people doing just this. In the same way that you don't need an entire room of people just calculating numbers to fill a spreadsheet. You could just have one person with a spreadsheet.
True. Yeah. So we've got a great question that I'd like to bring in, John, if you don't mind. And this comes from Cynthia. She asked, she was curious about your take on the timeline, signals, and barriers towards artificial general intelligence.
Versus our continuing on this narrow AI path.
Oh, you do see it too. Okay.
Yeah, I see it. That's good question. So people divide pretty evenly into techno optimists, techno pessimists, and I'm unusually kind of in the middle. I'm optimistic that we will indeed solve problems that we currently consider AGI, but I don't think we'll consider it AGI when we get there. I think we will change as humans as the technology changes. So what I mean by that, for example, is here's an analogy. So I think the most expensive document in the world, at least in the analysis, world, is the president's daily briefing. It's like a quick, 2-page doc once a day, but there's like on order of 10,000 people below it, entire intelligence community rolling up into it. And there's only one person in the world who can afford that right now, the President of the United States. I think in our lifetime, for sure, anyone can have their own presidential briefing. Something that, whatever your world is, whatever you care about, there will be machines that essentially do all this analysis for you and generate it, whatever format it needs, a document, or literally it could be an AI assistant who tells it to you in a short conversation. And when we get there, my claim is that we're not going to call that AGI. It's not going to be artificial general intelligence, because you're not going to be able to chat with that system about anything but that task. So a lot of people think that, well, if we could get there, if a machine system could generate something like that, something that complicated that requires 10,000 people and all this analysis and know-how and common sense thinking, then surely we will have solved AGI. And a lot of people believe that we will then hit something called the singularity, where an AI will, because it's as intelligent as us, surely it'll be able to design improvements on itself. And there'll be this explosive runaway where on the other side, it's impossible to predict what we'll face. And also whether our values will align with that thing and all that. That's the whole AGI cottage industry. I just don't think that's going to happen in our lifetimes. I just don't see that happening. I think that it could happen eventually, but like long before that, we're going to solve a whole bunch of problems that we're currently kind of talking about as if they're AGI or require AGI, but I don't think they do. I think that we can make really sophisticated systems with narrow AI that are going to do astoundingly useful things for everyone. But I don't think it's going to be true AGI. I don't think they're going to have personhood. I don't think we're going to be able to, have meaningful relations with them. I don't think they're going to even be self-aware. I think it's just going to be amazing machinery.
So is it your perspective maybe that multiple forms of narrow AI, many pieces loosely joined, will kind of approximate what we might today conceive of as AGI, or perceive of as being, well, once we get there, we've reached
Today.
AGI.
And once we get there, we're not going to consider it. There'll be a new frontier, and that'll be AGI. And by the way, that'll be AI.
Right. That's back to your God of the Gaps thing. It's like AI is whatever we can't explain, whatever we can't understand.
Yeah. The stuff that seems special to us because we can't build things to do it.
And Cynthia says, thanks, a very balanced perspective. Yeah, I like that. You're in the middle of the optimists and the pessimists. So
yeah, I mean, I'm very optimistic about narrow AI. I think that we're just scraping the surface of what's possible. To give you a sense, like right now we have these different silos of progress. We have a whole field called computer vision, and you're familiar with it. Started off, you could detect a cat. We had a cat detector. Now, like, you can synthesize images from scratch just by like letting an image generating the machine learning system kind of dream. So who knows where that's going? Hasn't even really entered the realm of video yet, but that's not far off. Meanwhile, you have language, it's its own separate thing. You have speech to text, it's been its own thing. They're just starting to come together though. We have a model now that we've been playing with from OpenAI that lets you move between language and image. So it was trained on a huge collection of images with captions. That was the great insight. Yeah, this is the data counterpart to OSINT, is open data. It's just huge collections of what we need are right out there if you can just think of using them right. So now you can say, for example, like generate an image of a chair that looks like an avocado, something that has never existed, and it will just do it. It'll just generate a whole gallery of things that are indeed chairs that are indeed in some way shaped like avocados. So that's fanciful, but like where it starts to get interesting is the reverse. Let's say you take all of the images that people are sharing on Twitter today, and then you map them using this model. So what it does is it actually creates a high dimensional mathematical space called an embedding space. And for any given image, it finds an address in that multidimensional space. It says, okay, you're there. You can do that for all the images. And then once you do that, you can use good old-fashioned distance metrics to cluster and search. And so the cool thing is now with these models, you can map from text into the same embedding space. So you could say, if you do that, map all those images from Twitter into the embedding space, and now let's do a search. I'm looking for a man in a red coat with a white hat, walking a dog near a red fire hydrant, whatever. You have some information. You're looking for something, you could just express it in English and it will find the images that actually match that. That's astounding. So that's where we're headed, is all of these different modalities, rather than having computer vision over here and language over there, it's all going to come together very, very quickly. It's already starting into one multimodal artificial intelligence toolkit. So that's what excites me.
Well, and I have to admit, as an analyst, my wheels start spinning about what sort of visualizations, link analysis becomes possible once those modalities dissolve into a single modality as well. Because one of the I will say one of the more time-consuming challenges of the analyst today is dealing with those multimodal sources of data and information, and making sure that they are that they are appropriately, reconciled and cross-referenced, those sorts of things.
Give me a concrete example.
So for example, let's say, a real world example, let's say pulling win-loss data from your customer relationship management system, so that, who are we up against? Who are we displacing? Whatever the rep was able to capture in that system in terms of a structured, why did we win? Why did we lose? Free-form text, pull down menus, those sorts of things, and then relate that back to a different data set of qualitative data based on, let's say, win-loss interviews with the reps, with customers, with other people involved in the pursuit, and reconciling those two very different data sets, actually more than two different data sets with completely different scales as well.
And that's all human labor right now.
Oh, it's a lot of human labor.
Yeah.
You're looking at the human.
Yep. Yeah. So I think the way that that part of your life is going to get better with these kind of tools is, in the beginning, it's not going to be some AI system that just does what you just described. It's not going to just out of the box kind of draw all those connections and kind of give you a report that tells you exactly what you would have found. I think rather in the beginning, it's going to be some tool set that you use to better search, to better, cluster, so that you have to use your human ability on fewer things more efficiently. So a good example, I mean, the best example that we all know in the age of Google is search. Search is remarkable, but it really just does this one thing, which is I'm trying to find things. Ultimately, I need to read them, but I can't read everything. So what I need to do is winnow down the things that I will consider reading. The next step of that, which is stuff that we've been building, is, okay, well, how about the machines read everything in advance? And so rather than have me have to read it, maybe I could read a summary of the things that are most interesting. And the level beyond that is, ultimately what I'm trying to find actually is the following. Maybe it's like, I need to know every company and every person and their relationship to each other mentioned in reports about some industry. Because I need to kind of draw a big picture and read in and figure out who the players are. A machine can do that now. As long as you can define what the pool of docs are and what that, represents that industry, a machine can go find all the people and companies, do relation extraction, figure out who works where, what relations those companies have, and just spit out essentially a report based on a knowledge graph that it's generating. So, and, we need to get to the point where you don't have to code to do that. You ideally, you can just express in English what you're looking for, and the system can interpret that, and hopefully with good ML explainability, which is like the features of the system where you can trust it and understand what it's actually doing, you can get to work. And now what took days of tedium is now really cheap. And I think that is the theme of this whole thing, is from the analyst point of view, this tech is cool. It's sci-fi. It has that, who knows where it's taking us kind of feeling. But at the end of the day, the reason you're going to pay money for it is because it actually helps you get to work. And so we think of it as reducing the cost of curiosity. Normally you'll have all of these questions you'd love to ask, but they're just so expensive to ask. Find me all the companies and all the people and their relationships in every document published last year in this industry that I need to get my head around. Great question. Really cool idea. Or maybe even, are any of those companies involve people who previously worked in China and now live in the US? Or, this is a company that actually shifted industry or has a supply chain that involves certain companies. These are amazing analytical questions that could lead to all kinds of amazing insights. These are hypotheses you want to test, but it's so damn expensive. You need a whole team of analysts just to get a start on this problem. So that's where the machine tools are going to come in, allowing you to just ask those questions and get an answer within 5 minutes, at least a first answer, a first cut. And, in the beginning, they won't be perfect answers. They won't be perfect tools. But, I mean, making your life 50% better is huge. Even if it's not 100%, if we cut, your pain in half, that's already getting pretty much a game changer.
Yeah. So what are some of the obstacles to making use of these technologies today that you've seen based on some of the work that you and Primer have been doing?
Well, I think one obstacle is there's a boring obstacle that we all face. This is just a technology in general obstacle, which is we all work at organizations that have technological interfaces that are pretty old. There's very few exceptions. We have legacy systems because they work. By definition, you stick with stuff because they work. And so when you bring in a set of technological capabilities that require a lot of changes to how an organization works, just technologically, how do you move data around? How do you have access? I mean, imagine in the intelligence community, if you have an AI system that needs to read everything and then will generate reports, how the hell does access privilege work? Does that thing, how do you, if a report is taking advantage of information that has mixed privileges, how do you manage access for anyone who's a consumer of that downstream? It's just super complicated. So there's all kind of just like boring problems in the way of AI in orgs. Then there's more interesting problems that are very new, like trust. So a good analyst, she uses tools she understands. And this is true in all the different kinds of analysis. You're not going to use something, you're not going to get adoption of some tool if you don't really know if you can trust it. Like it's not that you need to know exactly how it works. I can drive a car without needing to know how it's built.
I do every day.
But I have a deep understanding of the capabilities and limitations of my car. Like I trust that tool. I know it inside and out. And that's because of maturity. It's taken a long time for cars to get to that point. And so I think the same thing applies with machine learning tools in the workplace. There just hasn't been that much time. And so people, need to earn trust. We need to earn their trust. We who build such tools. So that's always going to be a friction, and it's good friction. It forces us to be honest. Like we have to earn your trust. So that's good. I think those are the two main ones. Another, there are other minor blockers, like essentially like sometimes a tool seems to be the right tool for the job, and then you realize the job itself is the wrong job.
Tell me more about that's really interesting. Tell me more about that.
So I'm coming from the engineering point of view. I've seen many examples of, we're falling all over ourselves to solve problems for analysts. That's what gets us out of bed. Sometimes you go way down the road with a customer and solve something really deeply, only to realize that was the wrong problem in the first place. And you you discover that together with the customer. Like actually, like we were automating something that really should have been done in a different way from the beginning. And so, that's also not, I don't think that's unique to machine learning and AI. I think that's just technology. If you're trying to help people with what they do in their workplace, you're on a journey with them. You're actually like, you're getting sewn into the fabric of their lives. And so it brings all the the blockers and tension of a life lived. So that's the long tail of problems. But I think the big ones is just old-fashioned technology adoption problems.
Mm-hmm. Mm-hmm. Well, and in some ways too, those technology issues, the adoption issues that you're talking about in terms of like, the time it's going to take for people to trust AI and NLP-based tools, also gives the technology the chance it needs to kind of breathe and to in some instances catch up to people's expectations.
Yeah, and I think it will take time. I mean, as excited as VC funding, funders are of all the startups who are trying to like blast into this space, we'll see how quickly the various kind of inroads actually work out. Some are going to be slower than others. I think the more mission critical the decision is that's being powered by whatever the work is, the slower it will be in general. The higher the barrier. So I think like the first stuff that's going to really just completely take over is the like low stakes but tedious things that machines can help you with. As opposed to, for example, I need to generate a briefing doc, and this briefing doc is going to be it's going to power a crucial decision for my organization. And, I'm not going to trust that to a machine. No way.
Right. So we've got a couple of really great questions in the chat that I'd like to pose. Cynthia raises another really good one. This is a really interesting one to me as well. How does the application of advanced technologies like NLP change our definition of what open source intelligence is?
I don't know. I mean, what comes to your mind? My mind's like racing in 4 different directions.
So one of the things that comes to my mind is first volume of information that tools like NLP open up for you. So just for example, you're moving from a case where open source intelligence might theoretically encompass everything in Factiva or everything that Reuters has ever written to no, really everything in Factiva, everything in LexisNexis and just on and on and on, to really truly encompass everything. So that's one dimension for me. And then another dimension on top of that is, do open sources now also potentially come with some of that analysis work done? I think there's not the most eloquent way I could have said that. But for example, does the New York Times now come with a semantic metadata layer on top of the human readable text?
It seems like a really good business pitch. In a way, that's kind of like what Bloomberg has kind of built its empire on. Well,
kind of, yeah.
Yeah. Well, the first thing that comes to mind is like you said, the scale. It's not just a change in amount; it's a change in kind. Once you go beyond
exactly
scale, absolutely. I mean, here's a real example. I was testing. Me and my team was testing out a new machine learning model, one of these little Lego bricks that does work for us. And to see if it worked, we tried it out on Elon Musk. So what the Lego brick does is, it's actually two Lego bricks. The first one finds all the named entities in text. So people, places, things, organizations. Imagine having a highlighter pen. You just, okay, in yellow, here's all the people. In green, here's all the organizations. Orange, those are the whatever. And then a second brick that takes the output of that and figures out what the relations are between those things. And the one we were interested in was, can you figure out where people have been? So you've just got all the world's news, and it mentions that someone was somewhere. So-and-so appeared on Capitol Hill and gave testimony. So-and-so was at a ribbon cutting. Blah blah blah. And you can imagine, if you were a human, it's like very bad task. You have to literally read everything. Maybe you have search, like give me the text chunks that mention a person of interest, but you still, like, if it's a famous person like Elon Musk, trust me, it's like unbelievably massive. So, machine learning to the rescue, a couple Lego bricks, plug them in, run the past couple of years, see what comes out. And what I've got is a timeline of everywhere Elon Musk has been before and during the pandemic. The guy's been everywhere. I mean, it was amazing. And, the model correctly identifies that he appeared in Clubhouse. It's not even a real place. It's like it's a cool audio community.
Right. Virtual place, kind of.
Yeah. And yet, correctly, he was there. He appeared in, New Mexico. He appeared here. He appeared there. And the scale of that, although it's OSINT, it's almost as if it might as well not have been, because there's no way any human, any team of humans, no imaginable assemblage of humans would have done that work. No one would have asked that question and managed to get that answer. And so, although it's OSINT as input, it's almost like you need these machines to access a secret layer of information that's hidden at scale in all of this. Something that is with us today that everyone should worry about, for example, is facial recognition at scale on OSINT. Photos of crowds of people in the street, are all over the place and right out in the open. But people can enjoy a private life because no human is capable of scouring through and finding absolutely every photo you've ever, appeared in. But machines can do that.
Yeah, no human, and maybe state actors can do that today, but very soon that might be something that's, through different technologies might be applicable to or available to more and more people.
Yeah.
And there's another great question in here, and this actually is, I'm going to be a little bit selfish to ask this question from Betsy as well. because we have some competitors that do this sort of thing too, where Betsy says there are many business and finance database vendors who say their resources include NLP. Oh, thank you for highlighting that. But does it?
Many businesses and finance database vendors who say their resources include NLP. What do you think are the kind of things they're doing for you with this NLP?
So we have some competitors that talk about applying NLP to, for example, databases of federal government contracts and federal RFPs and opportunities.
Mm-hmm.
And it all quite honestly sounds a little hand wavy to me, and a lot more sizzle than steak. And when you look at it, it's like, well, yeah, but what value are you really delivering here that's different from what we're delivering? And digging into it and having conversations with our product developers and talking about how they're using NLP and other technologies on the back end too, and does it get into a marketing issue if we're not touting it enough? I guess the question is, where is the proof in the pudding of NLP versus maybe more traditional, let's say token-based or search-based technologies that have, well, let's say in the last 15, 20 years, been kind of the standard approach of separating the wheat from the chaff. And I'm thinking about things like solar and stuff like that.
Well, to be fair, even if under the hood, someone using NLP on RFIs or whatever, even if under the hood all they're doing is good old-fashioned rule-based search, or like counting things, you can
exactly.
We've all seen word clouds, where it's really just like the size of the word is the frequency of the word in the document. So you can make a characteristic cloud of words that give you a glimpse at what this document is about. That's NLP. It's just old school NLP.
Right.
And it can be the right tool for the job. I mean, heck, search, pretty much a solved problem without deep learning. You don't need deep learning to power really good search for almost all use cases. And so, I think everyone is using NLP because it's kind of like the hot new thing. They're throwing that term around. In most cases, it's going to be old school NLP, but hopefully it's fit for the job. I think you have to judge by, what are you actually doing for me? What's the problem that you're actually solving? Are you doing it well? You shouldn't care whether or not deep learning is used or not. I think, I can smell BS pretty well now. I haven't spent 5 years in this industry. And most of it is laden with a good bit of BS whenever people claim they're using AI or ML or NLP. And it's okay. I think the customers will be the ultimate judge. What interests me is these new deep learning tools actually make it possible to actually solve your problems when before, with the old school techniques, they couldn't. So right. I think just, if it's a good product and it's actually doing what you care about, then don't worry about how it works. That's all marketing.
That's a good point. Yeah. So it's kind of like it's there, it's embedded. Everybody's kind of using pieces of it anyway, and it is kind of a marketing play as opposed to anything that's really substantive. Yeah, definitely agree. Ultimately, what is your view that the goal is for these technologies? What does the future look like?
Ooh, how far do you want to look ahead?
I'll settle for 5 right now, 5 years.
Yeah, I that's good, because beyond 5, who knows? It's just pure speculation. But 5, there's some trends underway now that are almost certainly going to play out. So let's focus on, in the life of analysts over the next 5 years, and the industry that they power. I think the most dramatic thing is that this spreadsheet for language technology, whatever it ends up being called, it's going to start to get commoditized, really easy to use, multiple vendors. So you can, be a choosy consumer, and they're going to work. And the things that they're going to actually work at are going to be really simple in the beginning. It isn't going to be some company that solves everything at once. I think it's going to be a whole ecosystem in the beginning. And then probably it'll coalesce. There'll be a few big winners. within 5 years. There'll always be a long tail of, startups. That's how innovation gets driven. That's okay. But I think NLP itself, or whatever we end up calling it, maybe we will just settle on NLP. Maybe that'll become a household term. I just doubt it. It sounds so wonky.
It is pretty wonky. Yeah. No offense, but yeah.
Also, I think that NLP isn't going to be NLP within like 5 years. By the end of 5 years, all of these different modalities, computer vision, speech, text, all of this is going to come together into unified systems. And so it's not going to be called NLP. It'll just be called AI, probably. It's good marketing. I think that in the timescale of 5 years, it's going to be stuff like Expensify. Expensify is one of my favorite examples of a wonderful solution for a common denominator painful problem. It does the one thing wonderfully. It deals with receipts in companies that need to keep track of expenses. But I've been playing with it a lot myself, scanning receipts and letting it, take a crack at it. You can do manually. There's a button you can hit, say, I'm going to do it myself. I don't trust you. I'm going to fill in the numbers and everything. But you can also say, hey, take a crack at it. It's getting better and better. And it's going to be stuff like that. Little discrete problems in life, in your day-to-day work, that are going to get automated. And these are going to be just good, simple tools. Hopefully by the end of this 5-year run, though, we're going to start to move up the food chain in the analyst workflow. I think that by the end of 5 years, it's going to be possible to generate reports with you, the human in the loop, but increasingly it's going to write the first draft of a lot of it. And it's going to take your directions. These are the assets that I'm interested in. Now let's pull them all together. And I think also it's going to do a lot of monitoring for you, especially in OSINT. So, you'll be able to just set up these automated analysts to do your bidding. So keep track of, and then you can describe what you want them to keep track of. Nowadays, all we've kind of got is keyword search. So in Google, they still have the service running. You can say, hey, if, these phrases show up, send me a digest. It's essentially just like a digest of Google search. So you don't have to do the search yourself.
Right.
That's going to get much more sophisticated. Within 5 years, you'll be able to say, I want you to keep track of all of the mentions of the following, the companies in this industry. And if you find any change in the C-suite, give me an alert, or keep track of all the changes in C-suites over, and pull it together into synthesize a report that gives me almost a Wikipedia page summary of changes in the industry over the past month. And hey, I want to share that with my team. So by the way, send it out as a email newsletter, or hey, I want this to power a dashboard for my team. And we'll have a few dashboards, and I want you to power that. I think we'll have that within 5 years, and I think it'll be pretty good. I think it's going to make life a ton better, but there's going to be a lot of pressure to make it even better. It'll be like, you'll feel that tension of I could have done that better myself. You can't, because you can't do it at that scale and you don't have time. But there'll be that tension of I could have done it better myself. I think after a 5-year period, when we get more to 5 to 10, it's going to feel like that amazing moment we've had with translation, where it went from, this is the worst translation, to I can pose as a Mandarin speaker on Slack now. And that could come really fast. I may be wrong. Maybe some parts of this will go faster than I realize. And within 5 years, we'll have, maybe briefing docs that are actually partly or entirely so good that they're now trustworthy. You don't need the human in the loop for some of them. I'm skeptical. I think it's going to take 5 solid years of using these tools in the industry, earning trust of users and iterating, working out all the bugs before we get to that machine translation moment for analysis. But we'll see.
Well, and I like your framing too about, the first draft, and, maybe the thing that if you send an intern off for, a month and said, go look at all of this, that'd be like the quality of what comes back in that situation or something like that.
Yeah.
maybe. And then, having different bots, for lack of a better term, handling the different piece parts of that, and then the analyst or the analyst team pulling that together into a finished product. I think that's, going back to one of the things you said early that really resonates with me is still that concept of lowering the cost of curiosity. Just being able to pose some of those crazy hypothetical questions that every CI professional kind of dreads when the members of the C-suite start, well, what about this? Well, what
Yeah.
about this? And being able to at least get a passable answer, or indication of, is that even worth looking into, with minimal effort, as opposed to killing yourself and the rest of the competitive intelligence team for 6 months to find out, like, that was really actually
It
not a
turns out it
question
wasn't that
worth
interesting
asking at all. Yeah. Yeah, just like
Exactly.
we're solving the wrong problem thing that you discovered. One of the things too that came up in our previous panel was this idea of small data sets, because right now the perception, and I see we've got a couple minutes left, but I'm going to try to sneak this one past the goalpost.
Yeah.
Usually today when we think of artificial intelligence based tools, we think of these enormous corpus of data.
Mm-hmm.
And one of the things I've always felt skeptical about competitive intelligence being an applicable field is so much of what we do is bespoke and on a relatively small data set to the volumes that I was hearing about. So as maybe a last question, I was wondering if I could pick your brain on that for a moment.
Yeah, I think that small data is the future. To build a lot of the basic tools of modern NLP, we've needed big data. So, I mean, these language models
Exactly.
are trained on like a huge sample of the internet itself. It's just billions and billions and billions of words. And you need that to build the base models. But some customer has some problem that they care about in their world. They're not going to have that scale of data. That scale of data won't even exist at all, period. It just doesn't exist. You need to train a classifier this is a real one I've heard before, to identify distressed properties, like, because you're a real estate developer or investor. And
Good
so
example.
what counts as a distressed property? Like, how many training examples can you imagine even exist? It's not going to be gargantuan. But if you're training a human analyst to do this, you only need a few examples. Like, you define, here's what I'm looking for. Here's some examples. Here's some edge cases that are or are not positive for this thing I'm looking for. Go off, work. So that's the future, is getting machine learning models to be like that human analyst who doesn't need a million examples to get the job done. And there's a couple big levers that we've discovered in machine learning scientifically to make that possible. One of them is just these more powerful base language models. They come with a lot of know-how out of the box. And another is just a lot of really clever techniques for finding those right examples that are most instructive to the model. So we've been building a lot of that at Primer. We have a whole product that does this called Automate, where you don't have to be a data scientist to build a machine learning model. And the tricks under the hood, they're all like things that help you find the best. It's like education. The weird thing is, like, to get to the small data paradise that we all want to be in, we actually have to bring all the tacit insights from the world of education science into the world of engineering. It's such a cool thing. I feel it happening all around me. I'll have meetings with my teams and we're talking about how to make this thing work. And ultimately what we're talking about is kind of like education problems. How do you teach this model the thing that's in my human head? And it's like, well, how did you get the human labelers to label those things? Well, we had these really good instructions and we found these really hard corner cases. Oh, cool. Well, how did you find those corner cases? Oh, well, it turns out there's this whole statistical technique for looking at a collection of data and then moving it around into a space where you can identify the neighborhood where the really hard examples are. These, by the way, they're the mislabeled examples. You better fix those. It's confusing the model. It's that kind of stuff that's going to get us there. We're knocking on the door, I'd say, of the small data world. We can make it work right now with a lot of finesse. And I think we're going to get the tools that make that really easy. And that's going to be great, because then you truly can, you're looking for distressed properties. You can just sit down, teach this machine what a distress property is. It runs off, and within an hour, it finds you a whole bunch of actual distress properties. Your day just got better. Something that was not possible is now possible.
That's fantastic. And a really great question came up. This is from Antonia, who was in our last panel and who was, I think, just blowing us all away with her comments about small data. She asked, is that an application of transfer learning that you're describing?
In a sense, all of the deep learning done in NLP right now is transfer learning, because you're taking a model that was trained to do this totally different thing, and it gained all these general NLP skills, and then you're fine tuning it on some task. It is, in a sense, transfer learning. There's kind of a fancier version of transfer learning where you fine tune it on this task, and you need to make it work in this new domain on data that it's never seen. So I think the small data regime is more the first rather than the second when it comes to transfer learning.
Okay.
And to answer Drew Ellis's question, Otter Space is the space defined by the otter. The team at Primer that builds the Automate product, they call themselves the Otter team. The otter is their mascot. So we're all about otters at Primer.
That's really fantastic. And what a great way to end with a little bit of learning and education about Otter Space. All right, John, thank you so much for joining us. Really appreciate it. This has been fantastic. I've learned a lot, and I'm looking forward to diving in deeper to a number of these topics.
It's been a pleasure.
And that's a great point, August. This is just the start, right? We've only scratched the surface to all of this. And so, so I look forward to continuing the conversation. And John, thank you so much for giving us some real thought-provoking concepts as well as timelines. A lot of people don't necessarily want to commit to that. So I appreciate your doing that and giving us, some guideposts at least, to follow. So thank you very much for this, and just for also satisfying my inner geek as well on the Intel and technology side. And I know I'm not the only one. So I'm in great company.